Math 1343, confidence intervals, common variables. Because in a statistics 2 class, students usually have a variety of experiences with statistics 1, I thought it would be a good idea to review some of the common variables we're going to be using in this class. This will not be a total list of variables throughout the entire semester. As we move forward, we will pick up some more variables. But most of these, maybe all of them, you might have seen from statistics 1. First things first, anytime you're talking about a population versus a sample, there is almost always a different variable for the same measurement. That's because of the nature of inferential statistics. If we're going to use a sample measurement to do something about a population measurement, we should represent them with different variables. Let's start with the size. The variable for population size is a capital N. However, realistically, you'll rarely know what that equals because, as was mentioned in the previous video, populations are either too large to measure accurately or dynamic in a constant state of change to measure their size accurately. However, when we select a sample from a population, we have complete control over how large a sample we select. I'm sure scenarios exist where we don't have complete control and we just gather a sample and then count it. But regardless, once you collect a sample, it has a size and its variable is lowercase n. As far as population and sample mean, just a reminder, mean is what most people commonly say is the average, where you add up the values and divide by the total number of values. There's a more specific definition of the word mean. In fact, there's multiple means we could talk about, but at this level, we'll just assume that mean is average. The variable for population mean is the lowercase Greek letter mu, which looks like a U, but drawn a little fancy with a couple of tails. If you were to spell it, it's spelled M-U, but don't ever spell it out. That's just for phonetic purposes. Greek letter mu is the variable for population mean. Now for a sample, the variable for its mean is an x with a bar over it, simply read as x bar. For population standard deviation, its variable is a lowercase sigma, which looks like an O with a little hair on it. The variable for sample standard deviation is just a lowercase s. And by the way, if either of these ever have a square on them, then it becomes something called variance. We don't use variance too much in this class. We will talk about it a little bit, but by far we use standard deviation more often. Proportion is percent, basically. For example, the percent of a population that has a characteristic or the percent of a sample that has a characteristic. So when you hear a statement like 8.5% of all the population is unemployed, that 8.5% is a population proportion because it's measuring the percent of a population that has a characteristic, in this case being unemployed. The variable for population proportion is just a lowercase p. But if you take a sample and measure what percent of it has a characteristic, for example, if we took 1,000 people and measured that 7% of them were unemployed, the variable for sample proportion is a p with a little hat on top of it, and that is commonly read p hat. Technically, this symbol is called a caret symbol, C-A-R-E-T, but in statistical circles, it's always just called a hat. All right, and again, we need variables for population versus sample for when we're doing inferential statistics and hypothesis testing, when we're using information from a sample to try to make some sort of inference about a population. Some other variables that we're going to see. I alluded to margin of error in the previous video. The variables for this are inconsistent. The variable I will be using is just its abbreviation in all caps, ME. And similarly, the abbreviation for standard error will be SE. These are not the same things. As we get into the nitty-gritty of confidence intervals, I'll attempt to explain the subtle difference between the two. We will be seeing both of them though. And of course, a z-score is just represented with a z. And if you watch the videos from last week, and hopefully you have, then we've seen z-scores already. We could also add a t-score to that, but I don't think that's necessary right now. All right, so know these variables, know them, know them, know them. Without them, you're going to get stuck early and often.